Talked about a few special cases, and now we're going to get into the general cases of projectile motion, and then the extremely general case of 2D kinematics that's not projectile motion. So first off, let's take a general case of projectile motion, and that's saying that something is fired or is thrown or whatever from some height. Okay, so it has some y naught, it has some angle, has some initial velocity, and it, follows the parabolic trajectory and goes down and winds up on the ground. All right. This is the most general case of projectile motion. Let's just take an example. Let's say that a cannonball is fired at 38 meters per second at an angle of 33 degrees above the horizontal from a hilltop 8.7 meters above ground level. So it starts out 8.7 meters higher than it lands. How long is it in the air? How far does it travel in the air? Now, these are the two questions we answered for our special cases as well. And remember, in order to answer this how far does it travel question, we first had to answer the how long it is in the air. So I asked both questions here, but if you're just asked how far does it travel, you need to figure out the answer to this question first. So we have our equations. We know that our y equation, our y final is 0. Y naught is initial height. That's our 8.7 meters. V naught y. Well, we're at 33 degrees. Our initial velocity is 38, and we're at 33 degrees above the horizontal, so that's 38 sine 33 for the y component of the velocity times time. And our acceleration is the acceleration of gravity, so that's minus 9.8 meters per second squared, so half of minus 9.8 is minus 4.9 t squared. And we can punch that into our calculator and find that t equals 4.6089, etc. seconds. Now there's also a 0 at there's also a 0 at t equals minus 0.385 seconds, but t equals 0 is when our equations become valid, and so we ignore the negative time answer. So this is how long it takes to hit the ground, and then how far does it travel? We're just plugging that value into the x equation. Our x position is equal to, we can call our x naught 0, our v naught x is just 38 cosine 33 t, and there is no acceleration in the x direction. So we can plug in this 4.608 for t, and we come out with, by the way, on your calculator, I've gone calc 0, right, and I got that 4.608, and that value automatically stores itself as x. So now if I go back to the home screen, I can type 38 cosine 33 times x and just get my answer that way, because x is the 4.608. So the distance it travels is 146.8852, etc. And wherever you truncate this, I guess you should round it. Remember, we don't care about sig figs. You can round to wherever you want. Just don't round to fewer decimal places than we're given in the problem. And so it went 146.89 meters. Okay, now let's ask another question. Let's say, how high did it go? And this is something that we can answer in the same way we did when it was fired from ground level. We want to know how high it went. Well, what do we know at the highest point? We know that the y velocity is 0 at the highest point. So we can take this, a equals delta, well, we could do that. Sorry, that would be easier. The easiest thing to do would be to take this, because we know that 2 times the acceleration in the y direction, minus 9.8, times delta y equals v final y, which is 0, minus v naught y, 38 sine 33, squared. And if we do some algebra, we figure out that our delta y, 38 sine 33, squared, And then we divide by, and that should be negative, but then the 9.8 is also negative, and so the negatives cancel out. Divide by 2 times 9.8. We get that our delta y is 21.853, etc. But we have to be careful here because this is delta y, and delta y is y final minus y naught. So at our highest point, we're actually higher than that because our y naught was 8.7. So our y final is that plus 8.7. Oops. And so that comes out to 30.55 meters. Sorry, that looks like an 8. It should be a 30.55, even though yeah, it's a bad 5. Oh well. That's another question I could ask you. I could also ask you, what is the cannonball's velocity as it hits the ground? Just so you know, when we're talking about projectile motion, we never really care what happens after it hits the ground. We're only concerned with up to that point. So when I say as it hits the ground, we're talking about when y equals 0, like that instant. Well, we already have our time, so we could use that and calculate it. But again, we can use the time-independent equation. We have 2. Our acceleration is minus 9.8. Our delta y is y final minus y naught. So that's 0 minus 8.7. So that delta y winds up being negative because we wind up lower. If we wind up lower than we start out, our delta y is negative. If you're using the standard up is positive, down is negative. Although, remember that what you assign to be positive and what you assign to be negative is arbitrary. It's just what matters is that you're consistent. Equals our v final y squared minus v naught y, which is 38 sine 33 squared. Remember, this is the equation for the y direction. So when we get this, this is not going to be our answer because our v final x is the same thing as our v naught x, which is 38 cosine 33. So we're going to have to, put those together, do magnitude and direction. Just don't get caught in the trap of thinking this is your total final velocity. If we do some algebra there, what do we have? We've got 2 times minus 9.8 times minus 8.7, and plus 38 sine, parentheses, 38 sine 33 squared. And that's equal to v final y squared. So we square root that, and we get our v final y squared. Our v final y is 24.471, etc. Okay, but remember, since v final squared equaled 598, so it could be plus or minus 24. And in fact, we know that when it hits the ground, the ball is going to be moving downward, so we know this should be a minus 24.471. That sign will appear automatically if you use this thing instead. If you use the time independent, you have to think about it a little bit because it could be either the positive or the negative. Anyway, then our v final is square root of v final y squared plus v final x squared. So I guess for that you didn't really need to square root it. But that squared plus 38 cosine 33 squared, square root. So our v final is 40.18 meters per second. And our angle is the arctan v final y over v final x, which we punch in arctan of, oh shoot, I didn't store it. There it is, plus 38 sine 33. You should always store your answers. It makes things a lot easier. Square root, answer. There we go. That's our y velocity. So arctan answer over 38 cosine 33. And we get 37.5, etc. degrees. And that's going to be below the horizontal because our y velocity is negative and our x velocity is positive.